Good day guys and welcome to Intellect Academy. Today we are going to be talking on resistance. Resistance is the opposition to the flow of current in an electrical circuit. Now, the device that is responsible for the opposition of current is called the resistor. So the resistor is the device which is an electronic or electrical device that oppose the current. So take note, the resistor is the device that opposes the flow of current. Now take note, in conductors, of course, we know that conductors are materials that allow current to flow through them. Conductors have low resistance. Conductors have low resistance, while insulators, of course, we know that insulators are materials that do not allow current to flow through them, have high resistance. So this signifying high is going up, while this signifies low. So that is very important. You should know that conductors have low resistance and insulators have high resistance. Now, the resistance of a conductor or a material varies or increases or decreases with some particular parameters. Number one is the resistance of a conductor is directly proportional to what? The length. The resistance of a conductor is directly proportional to the length, in the sense that if the length of the material or the conductor increases, the resistance also increases. Now, you should also know that the resistance is inversely proportional to what? The area, also known as the cross-sectional area. This area is the area of the material, or in this sense, a conductor. So this is equation 2. Combining equation 1 and 2, we have that we have the resistance is directly proportional to the length and inversely proportional to what? The area. Now let's call this equation 3. If we remove this proportionality sign and bring an inequality sign, anytime we do that, we introduce a constant to the right hand side. So we have that the resistance is directly proportional to what? A constant multiplied by the length over the area. So let's call this equation 4. Where this is called the constant of proportionality. So now this is called the constant of proportionality, also known as the resistivity. So now this is the resistivity of the conductor, where we know the length L is the length of the conductor, and we know that A is what? The cross-sectional area of the conductor. So now take note, we have that the resistance is equals to what? The resistivity multiplied by the length all over the area. Now this is how we calculate the resistance of a conductor, knowing the resistivity, which is also measured in what? Ohm meter. So the unit for resistivity is ohms meter, where resistance is in ohms. This is in ohms meter, this is in the length is in meters, and the area is in meter square. Okay, now there are some factors that determine the resistance of a material. Now take note, from this relationship here, we can see that the factors that affect the resistance of a conductor. So we have factors that affect the resistance of a conductor. Number one is what? The nature of the material. We have the nature of the conductor or material. Two, we have what? The length of what? The conductor. So we have the length of conductor. Three, we have the cross-sectional area. Four, we have what? Temperature. So these are the factors that affects and determine the mass of the conductor. Let's talk about conductance. Conductance. Okay, now let's talk about conductance. This word is coined from what? A conductor. So if we can determine the resistance of a material, we can also determine what? The conductance of a material. Conductance is given by G, capital letter G. So now take note. The conductance is the inverse of what? The resistance. So we're having conductance is equals to what? The inverse of what? Resistance. That means we're having that G is equals to 1 over R. But we know that R is equals to what? Resistivity multiplied by the length all over the area. When we substitute this into this, we're having our G is equals to 1 all over bracket the resistivity multiplied by length all over the area. Now, once you perform an operation here, you will see that the area will come up. So we're having that this is equals to the area all over what? The resistivity multiplied by the length. But we know that the conductivity is equals to the inverse of what? The resistivity. The conductivity, which is given by this, conductivity is equals to the inverse of what? The resistivity. So once we do that, we are having that G, which is the conductance, is equals to what? The area, the conductivity multiplied by the area all over the length. So let's call this equation 5. So take note. This is the formula for what? The conductance of a conductor. Where we know that this is measured in what? Because of we knew that the resistivity is measured in ohms meter. That's to show that the conductance is the inverse of the resistivity. That means the unit for the conductance will be what? Ohms per meter, Newton per meter. Or you can call it ohms meter or minus 1. Very, very understandable. Ohms meter all in to minus 1. Raised to power minus 1. So this is the unit for the conductivity of a conductor. So now let's take some sample problems.